बिस्मिल्लाहिर्रहमानिर्रहीम। तो आज हम एटॉमिक एब्जॉर्प्शन जो हम स्पेक्ट्रोस्कोपी पढ़ते हैं, एटॉमिक स्पेक्ट्रोस्कोपी, उसमें तीन इम्पॉर्टेंट कॉन्सेप्ट्स हैं। वन इज एटॉमिक एब्जॉर्प्शन स्पेक्ट्रा, सेकंड इज एटॉमिक इमिशन स्पेक्ट्रा एंड थर्ड इज एटॉमिक फ्लोरेसेंस स्पेक्ट्रा। इन तीनों में क्या बेसिक डिफरेंस है, क्या बेसिक मैकेनिज्म है इन तीनों में, तो how the questions can be asked in the objective type exam from these three topics which are in the syllabus. तो हम स्टार्ट करते हैं एटॉमिक एब्जॉर्प्शन स्पेक्ट्रा। तो बेसिकली ये तीनों दे आर यूज्ड फॉर द क्वालिटेटिव एंड क्वांटिटेटिव एनालिसिस, यानी किसी भी सैंपल में कौन सा एटम प्रेजेंट है और उसकी कॉन्सेंट्रेशन कितनी है, उसका अमाउंट कितना है, दैट इज द output of these three techniques. And most among these three techniques, atomic absorption is widely used techniques. It has more advantages compared to these two. So we'll start with atomic absorption now. Atomic absorption को understand करने के लिए, so जैसे हमने कहा था कि atomic absorption spectroscopy में interaction of electromagnetic radiation with atoms, not molecules. अब अगर सैंपल में, क्योंकि सैंपल में तो फ्री एटम्स ज्यादा नहीं हो सकते, सो व्हाट विल डू इफ यू हैव मॉलिक्यूल, so we'll break the molecule into the atoms and that is called as atomization. ये हमने किया था. So once your free atom is present in the gaseous state, now we can study these, we can analyze these. ठीक? So this interaction of electromagnetic radiation with the atom, so what it does is it involves these three processes. This interaction can be expressed through these processes. Number one, atomic absorption. तो एटॉमिक एब्जॉर्प्शन में वी नो क्लासिकली हमारे पास जो एटम होता है, there's a nucleus and then there's an extra nuclear part, the energy levels, where we have electrons. So once the atoms interact with the electromagnetic radiation, so let us say, so that wavelength which has energy gap equivalent to, which has energy equivalent to this energy gap, E2, this is E1, जिस रेडिएशन की एनर्जी इसके बराबर हो, that only will be absorbed and then it will lead to the excitation. So we have a state now like so we have electron here now. So this is the excited state of atom. So we're going from, this is called your ground state, which is present in the gaseous. So मैंने कहा था यहाँ पे कि जब हम इसको ब्रेक करते हैं इस मॉलिक्यूल को into atoms, these are the gaseous state. तो gaseous state में when we interact the radiations with this our sample, that is the atoms, so if it has that appropriate wavelength present, that only wavelength will be absorbed by the atom and it will lead to the excitation. So that means we are going from ground state to the excited state. That means जो भी एलिमेंट है उसके जो एटम्स है उनकी एक स्पेसिफिक ये गैप होती है, E1 E2 गैप, यानी उनकी एक स्पेसिफिक गैप होती है. ये गैप हर एटम की अपनी अपनी अलग होती है. So that means with the help of using this characteristic property of atoms, or using this signature of atoms, that they absorb only a particular wavelength. ठीक? So they absorb only a particular wavelength. So with the help of this we can detect the type of agent, because different atoms absorb different atoms, they absorb their characteristic wavelengths. So this this property can be utilized. With the help of this property, we can detect which type of atom is present in the sample depending on which wavelength it absorbs. So basically in the atomic absorption spectroscopy, we are dealing with this component of the light absorbed. And now how much amount of light is absorbed, that depends upon how many type of atoms are present in the sample. So that intensity of the light absorbed will give us the concentration. So the intensity of that wavelength, that particular wavelength absorbed, so that is directly proportional to the concentration, or that is directly proportional to the amount of atoms in the sample. So this is the basics of the atomic absorption spectra, where we actually deal with the amount, that specific wavelength which is absorbed, and that actually leads to the conversion of the ground state of atom into the excited state. तो ये हो गया basics of the atomic absorption spectra. So this is your atomic absorption spectra in general, and this is the most common form of atomic spectroscopy used for the chemical analysis, that is for detecting the amount of element present and which type of element is present. Fine. उसके बाद दूसरा कॉन्सेप्ट है, दैट इज एटॉमिक इमिशन. एटॉमिक इमिशन में हम क्या करते हैं? सो लेट अस जस्ट रब दिस. So second is the atomic emission. Spectra. एटॉमिक इमिशन स्पेक्ट्रा में हम लोग क्या करते हैं, जो हमारा सैंपल होता है, सैंपल को थ्रू द एटमाइजेशन प्रोसेस वी आर कन्वर्टेड दिस इनटू द एटम्स प्रेजेंट द गैसियस स्टेट. ठीक, हम जानते हैं ये जो एटम कन्वर्जन है, हम वी कैन डू विद हेल्प ऑफ द फ्लेम, what we call as the flame atomization. So they are basically the upon absorption of that thermal energy. So we have atoms present, we have sample now present in the form of free atoms in the gaseous state. तो यहाँ पे atomic emission में, so what we do is that we it is these atoms, they are subjected to the radiations from some source. उन पे जैसे मैंने कहा कि एटॉमिक स्पेक्ट्रोस्कोप में वी आर इंटरेक्टिंग विद रेडिएशंस, तो यहाँ पे भी वी आर इंटरेक्टिंग विद रेडिएशन, लेकिन उनका सोर्स होता है, द सोर्स ऑफ दीज रेडिएशंस इज electrical arc or the source of radiations can be a flame, most commonly a flame, or it can be plasma. बेसिकली यहाँ से हम इनको थर्मल एनर्जी प्रोवाइड करते हैं. तो थर्मल एनर्जी प्रोवाइड करने से क्या होता है कि these atoms, they are getting converted into their excited states. So upon absorption of thermal energy, the atoms are getting converted into excited states of atom. That means, so excited state of atom means initially it was like this. So your electron is getting excited from ground to. So initially it was in the ground state. After excitation, after absorption of energy, so your atoms in the excited state. That means electron is present here. Fine. Now, उसके बाद basic start होता है in the atomic emission. तो यहाँ पे what we do, we are basically interested in, क्योंकि excited states तो stable होते नहीं, so the electrons will try to come back. So once they will come back in the ground state, that means molecule will come, that means the atoms will come in the ground state, so it emits the radiations. So there's emission of radiation. When it emits the radiation, so we are basically detecting those emitted radiations, and the radiation emitted that is characteristic of a particular atom. Absorption की केस में we are dealing with the amount of radiation absorbed. यहाँ पे जो emit radiation होती है वो भी कैरेक्टरिस्टिक होती है, यानी इसकी जो एनर्जी होती है इस रेडिएशन की, दैट इज इक्वल टू द एनर्जी डिफरेंस बिटवीन द टू एनर्जी लेवल्स, that is E2 minus E1. Now, as the wavelength of the radiation emitter is characteristic of the atom, so with the help of emission spectroscopy, we can detect which type of element is present or which type of atom is present in the sample, and the intensity of the radiation emitted, that will give us the concentration. So this is the basics of the atomic emission spectroscopy. For example, अगर हमने सोडियम को excite किया, so we have sodium in the excited state, so it will emit, it will come back in the ground state with the emission of radiation, and that radiation has a wavelength around 588 to 589 nanometers. Take, and you will see the beautiful, that is bright yellow light, bright yellow emission color. Take, bright yellow light. So it will be always that you will get this wavelength for the sodium, and for different elements the emitted wavelength will be different. So depending on this, since this emitted wavelength is characteristics of a particular atom, so that is used to detect the presence of element in the sample, and the amount of the radiation gives us the concentration. So this is the basics of the atomic emission spectra. यहाँ पे हम atom को excite करते हैं with help of thermal, we are supplying the thermal energy that can be either the electrical arc, that can be flame, that can be plasma. So this is the basics of the atomic emission. Now we have the atomic fluorescence, the last one. So we have the third one, that is the atomic fluorescence. So this is the third one, that is atomic fluorescence. Okay. The atomic fluorescence में क्या है? This basically, this technique, it combines both. So this involves both absorption and emission phenomena. So it is basically the output of both absorption and emission technique. And atomic absorption plus atomic emission will give us basically the atomic fluorescence technique. ठीक? But now in this case, the atoms जो ground state में होते हैं, now atoms in the ground state means classically हम ये दिखा रहे हैं. So we have electron here. So this is atom in the ground state. Now that atom in the ground state, this is interacted with radiation. Now that radiation is basically created with the help of flame, and it absorbs energy from the flame. एक flame होती है, उस flame की help से the atom is getting into the excited state, that is your electron is getting excited. So we have the atom is now excited state with the help of flame. So here the ground state atoms, जो ये atoms कहाँ से बनते हैं, जैसे हमने पहले भी कहा कि जो molecules है, that molecules we are heating them on the flame. ठीक? That's called as a flame atomization. So we have free atoms present in the gaseous state now. So the free atoms are present in the gas state, they are excited. So अब ये जो free atoms हमें जो बनते हैं, they are excited with the help of they are excited usually with the help of UV light. So they are excited with the help of UV light. The flame is basically used to create these free atoms. अब जो free atoms होते हैं in the gaseous state, they are excited with the help of beam of ultraviolet radiation. तो एटम पे जब हम अल्ट्रावायलेट रेडिएशन यहाँ डाल लेते हैं, जिस एटम को क्रिएट किया गया था विद द हेल्प ऑफ फ्लेम, सो नाउ वी हैव द एटम प्रेजेंट इन द एक्साइटेड स्टेट. सो द बीम ऑफ लाइट, यूजुअली यूवी, दैट इज incidented, or we can say that is interacted with the atoms, and then we have the atoms in the excited state. ठीक? Then यहाँ पे क्या, this decay, then this emission of electrons back, it is not necessarily it may come directly. there are some sub energy levels, you can follow this path also. So this, how this electron comes back, how the atom comes back to the ground state, I should say, how this atom comes back to the ground state, it can follow different paths. It can follow the different paths. So in the emission technique, the emission result is the decay of atoms from the excited source. Now this decay, this path, how it comes back, this is actually taken into consideration. और हम जानते हैं if it comes directly back, that's called a fluorescence. And then in the fluorescence जो एनर्जी यहाँ पे इसने एब्जॉर्ब की थी रेडिएशन की, ये जो वापस आ जाता है, it is slightly less. So the emitted energy, that is less than the wavelength which was where it was excited, because some thermal processes, usually it is greater than that. So usually जिस light से हमने UV light से इसको excite किया था, and you will get the emitted light here. वापस जो light यहाँ से निकलती है, so that will fall either in the UV visible region or it can fall in the visible region only also. Ideally होना ये चाहता है कि it absorbed the UV and then should come back with the UV. ऐसा नहीं होता in the fluorescence. यहाँ पे जो electron वापस आ जाता है, it can follow different paths also. So usually the wavelength that is emitted is less than, that means the wavelength of the emitted light, that is larger than the wavelength of the light with which it was excited. So that's why the emitted wavelength usually fall in the visible, but not necessarily visible, it can fall in the ultraviolet region also. So with the help, now ये जो यहाँ से जो हमें wavelength निकलती है, that is specific of a particular atom. So with the help of that we can determine which type of atom is present in the sample and the amount of light which is released, the amount of the UV or visible light which is re-emitted from here, that gives us the concentration in the sample. So this is all about the basics of the atomic fluorescence. Of atomic fluorescence में और थोड़ा सा यहाँ पे एक important diagram है यहाँ पे atomic fluorescence में. So we have the lamp, UV lamp, जहाँ से हम UV radiation generate करते हैं. So this is your UV lamp. The UV lamp में we have the radiations, okay. So they continuously fall on that flame. This flame where there's conversion of molecules into atoms, continuously there's flame on that, and then it falls on the detector. और ये होता है कि डिटेक्टर और लैंप जो है, they are oriented at an angle. ठीक. So in this case the detector, the source lamp of source of ultraviolet radiation, and the lamp, source lamp and the detector, so they are mounted at an angle. आप देख सकते हैं it is at an angle. So they are mounted at an angle. So the lamp, the source lamp that generates the ultraviolet radiation for excitation of atoms, जो atoms यहाँ पे generate हो जाते हैं near the flame. So and the detector, they are mounted at an angle. अब ऐसा क्यों होता है? Now why it is this? Because sometimes the, क्योंकि ये flame की भी अपनी जो flame होता है वहाँ से भी अपनी एक it has some color. So यहाँ पे detector ये color भी, it can detect the color also. So in order to remove this, we are keeping this source lamp at an angle so that it can only detect the angle. It can only detect this the source radiation. So the source lamp for the atomic fluorescence is mounted at an angle so that the light detector sees only the fluorescence in the flame. So flame मैंने कहा कि इसकी अपनी एक वो जो कलर टाइप होता है फ्लेम में, और दूसरा फ्लोरेसेंस इन द सैंपल. बेसिकली यहाँ पे एटम्स, यहाँ एक साइड से फ्लेम भी होता है, जहाँ पे मॉलिक्यूल्स आर कन्वर्टेड एटम्स, दूसरी साइड से एटम्स आर गेटिंग एक्साइटेड फ्रॉम ग्राउंड टू एक्साइटेड स्टेट, तो वहाँ से डी एक्साइटेशन के बाद दे आर इमिटिंग द फ्लोरेसेंस लाइट। तो यहाँ पे दोनों पॉसिबिलिटीज थी कि इट कैन डिटेक्ट दी जो कलर इसका था, जो फ्लोरेसेंस इसका था फ्लेम का, तो डिटेक्टर कैन डिटेक्ट दैट आल्सो। इन ऑर्डर टू रिमूव दैट, इन ऑर्डर टू मेक द डिटेक्टर डिटेक्ट ओनली दिस लाइट, the source lump and this detector, they are aligned at an angle. So this is all about the basics of atomic absorption, atomic emission and atomic fluorescence technique that's used for the qualitative and quantitative estimation of atoms in a given sample, whether it's environmental, whether it is water sample, geo sample, soil sample or whatever. So basically we have fluorescence, this is the output of this plus this, so it's both combines technique, both techniques combined. So this is the basics. I've tried here to make this so simplified as much as possible, looking at our objective type exam, or so I've tried my best here. So this is all for the day. Subhanallah.